Okay, now we are going to do Chapter 6, use Cramer's rule to solve for y. What you first start by doing is writing this first part of the equation before the equal sign as a matrix. So A equals matrix 2, 1, 5, 3, 1, negative 7, negative 1, negative 3, 2. And that's your A. And your AX equals, and then you take the equal sign and plug that into the regular matrix right here where the 2, 1, and 5 are. So you get AX equals 1, 12, 28, 3, 1, negative 7, and negative 1, negative 3, 2. And you repeat that process for AY, but the 1, 2, and 20 go over 1, and the 2, 1, and 5 come back. Watch carefully. AY equals 2, 1, 5, 1, 2, 20, 1, 12, 28, my bad. And then negative 1, negative 3, 2. And then you take you want to find the determinant of AY, and you do the matrix as determinant AY equals 2, 1, 5, 1, 12, 28, negative 1, negative 3, 2, and then you repeat the 2, 1, 5, and then 1, 12, 28, and that's your matrix to help you find the determinant. And then what you do here is you multiply the 2, the 1, the 12, these right here, and then the 1, the 3, and the 5, and then the 1, and the 28. You multiply those and then add them all up. I will just tell you that it is 5, and then you repeat the process on the 1, and the 2, the 2, the 3, negative 3, and the 28, and then the 1, the 12, and the 5. You multiply those together and then add them all up, which will give you negative 196. And then you do 5 minus 196, which is really 5 plus 196, and they'll give you 201. And then you want to find A, just regular old A, okay, right here. You do the same process that we did for the determinant of AY, but instead you just do that with the A matrix right here. You do A equals 2, 1, 5, 3, 1, negative 7, and then negative 1, negative 3, 2, and then you repeat the 2, 1, 5, and then the 3, 1, negative 7. And then you multiply the 2, the 1, and the 2 together, the 3, the negative 3, and the 5, and then the 1, the negative 1, the 1, and the negative 7 together, and all that will give you is negative 34. And then you repeat the process for the 3, the 1, and the 2 right here, and then the 2, the negative 3, and the negative 7 right here, and then the negative 1, the 1, and the 5 right there, and then when you multiply those three together, it'll all give you negative 43. And then this one gives you all 34. And how I got that was 2 times 1 times 2 is 4. For example, like the 2 times 1 times 2 is 4. And then the 3 times the negative 3 times 5 is negative 45. And then the negative 1 times 7 is 7. So I do the 4 plus a negative 45 plus 7, and that's how I got the 34, for example. And then you repeat the process on the other side. So then I do negative 34 minus 43 equals negative 77, and that's the determinant for this one right here. And I do y equals the determinant of ay over determinant a, and that gives you y equals 201 over negative 77, and that equals negative 2.61039 equals y. That gives you that. And that's how you use Cramer's rule to solve for y. Now, for part 2 of chapter 6, we must find the values of x using inverse matrices. This is going to be fun, I can tell you that. So, you start by writing your original matrix. And what you're going to see me do here is that I'm going to move one line up a bit so that the 1 is in the correct spot. So how the matrix I'm going to write looks like this. So as you can see here, originally the 1, 1, and the 3 were down here, like where the 2, 3, and the 1 were. I just moved them up because it would be easier. So now what I have to do is negative 2 times r1 plus r2, and then negative 5 times r1 plus r3. And then that'll take me down here a bit. So 1, 1, negative 3, 0, 1, 5. If you do all the equations, this is what it'll get you. And 0, negative 12, 17. Then we got 1, 0, 0, negative 2, 1, 0. 0, negative 12, 17. Oh, wait, hold up, my bad. This one is negative 5, 0, and 1. Pardon me. And we do negative r2 plus r1, and then 12 r2 plus r3. And then I'll take you down here to 0, 1, my bad, 0, 1, 0, negative 8, 0, 1, 5, 0, 0, 77, 3, negative 1, 0, negative 2, 1, 0, negative 29, 12, 1. Then we do R3 divided by 77, and that'll take you down a bit right here to 1, 0, 8, 0, 1, 5, and 0, 0, 1. And then we got 3, negative 1, 0, negative 2, 1, 0, negative 29 77ths, 12 77ths, and 1 77th. Then I do 8 R3 plus R1, negative 5 R3 plus R2, and then this will take me down a bit to here. So I get 1, 0, 0, 0, 1, 0, 0, 0, 1. And then this gets fun. negative 1/77, 19/77, 8/77, 299/77, negative 17/77, and negative 5/77. And for the third row, negative 20/77, negative 29/77, 12/77, and 1/77. The same as up one line because that didn't change. And then I do over here, I'm going to bring all this stuff up here, carry on my thoughts. And then I do X, Y, Z, and equals a negative 1, 1, 12, 28, 1, 12, and 28. So I multiply this big matrix, this inverse matrix down here, right here is the inverse. Multiply all that by 1, 12, and 28. Multiply all that together. Multiply these two matrices. And then this will give me I add them, and then that gives me 41/7 because x equals negative 1/77 plus 2/28/77 and plus 2/29/77. And then that's the values of x, and then x, yeah,